Some series to integral calculus. Some series to integral calculus. Some series from integral calculus. Some series through integral calculus. To integral calculus, from integral calculus to integral calculus. Democracy is by the people, of the people, for the people. Okay. So mathematics is by the integral calculus, of the integral calculus, for the integral calculus. Means you generally, no one can see any computation that cannot be achieved through integral calculus. Differential calculus is someone can say that opposite to integral calculus, anti-integral or reverse integral or whatsoever. Okay, so integral calculus does everything. Someone can do the summation, multiplication, division, everything. It is more towards it. If two items are being multiplied and one is function over another, then there is no other way than going for integral calculus. Otherwise, simple multiplication can also be done through integral calculus. After all, simple multiplication is nothing but calculation of area of a rectangle where the simple multiplication operands are two sides of rectangle. Operator, operand. Two sides of operand of the multiplication are two sides of rectangle. And this is about two sides multiplication is achieved through the integral calculus. Integral calculus is a way to compute area. Okay, what is another definition of integral calculus? Integral calculus has only one definition. If there are two operands in multiplication, people can loosely understand in this manner. If there are two operand of multiplication and one operator is there, then one operand will become x-axis and another operand will become y-axis. And when the y-axis, that is the vertical, y-axis means vertical, at different x, the y-axis is different. That is also known as function over x, because if you change x, then vertical would change. In that manner, that is one way of thinking of area. Okay, too many fundamentals. If I have to multiply two items, one item is A and one item is B. A into B. B I can consider as x-axis and A I can consider as y-axis. Means A is height and B is width. Then I can draw a graph. This is B, I can say x-axis, and this is A, that is called y-axis, A into V. At different B means different x, what is the vertical? So if I say I have 3 into 2, then along x-axis I have 0 to 2. Whereas along y-axis I have 3. 3 into 2, 3 is vertical. But the miniature science is that between 0 and 2, there are infinite points exist on x-axis between 0 and 2. And for each x, there is a vertical. For each x, there is a vertical. If I say 3 into 2 means between 0 and 2, there is a vertical that is always 3 at irrespective of what x I take between 0 to 2. Whatever x I take, if I draw vertical, height will be 3. Means if I draw a graph, then graph will form a rectangle whose height is 3 and width is 2. At any x between 0 and 2, the height is always 3. The height is always 3, but it may not be the case always. Like sine x into x, sine x into x. Okay, what do you mean? Now, multiplication of algebra. Sine x into x, where sine x is variable with x. If I take x between 0 and 2, then the height will be sine x. If x is 0, height is 1. I'm sorry, 0. When x is pi by 2, then height is 1. When x is pi, then height is 0. Means height is varying with the x-axis. In that manner, what is the area? This is sin x. What is the area underneath it? If height is varying at different x, if this is the sin x, up, oh, okay. Okay, this is sin x. Then if I take x here and draw a vertical, it will go and hit the curve. If I take x here, draw the vertical, it will go and hit the curve at maximum height. At different x, height is varying. Okay, I can have that kind of scenario, sin x into x. Okay, whatsoever. Integral calculus is purely if I have x-axis and if I have a graph, then what is area of it? That's it. It's a science to calculate area. Okay, but you said it is integrand, operand and operator and something like that. Consider there is a graph and where the top is flat. There is a graph where top is flat. Then I can say x is going like this, but vertical is not changing. It is always constant. Then between 0 to any point or between any 2 points, if I take a set of y, then it will form a rectangle. Then if I say integration of 5 into x, where x is x-axis and vertical is always 5, 5 into x, how to calculate area? The notation is fx dx integration sign, limit sign, where lower limit of x to higher limit of x. If I have a rectangular region, then I can say 5 into dx. dx is from lower limit to higher limit. If lower limit is 0 and higher limit is 4, then at the end it will become 5 into 4, that is 20. This is a mere a chance that integral calculus, when it is calculating the area of different shape, one shape is there where the height is always constant irrespective of x, and that shape is called rectangle. And fortunately, unfortunately, the area of rectangle, when we calculate through integral calculus, it comes in a form of multiplication of two sides, where one side is x-axis, one side is y-axis. That's it. And we can say integral calculus is superset of multiplication, because integral calculus calculates area of many shapes. In that, one shape is rectangle and that breaks into multiplication of two items. Means multiplication of two items is subset of integral calculus. Integral calculus can have many areas. Anyway, can we use integral calculus to calculate summation of items? The example we have taken is 2 to the power minus 2x. What I mean is, in examination, question is written 2 to the power minus 2 plus 2 to the power minus 4 plus 2 to the power minus 6 plus 2 to the power minus 8 plus 2 to the power minus 200. Now calculate it. This is what is written in the examination. This is what is written in the examination. Can you please calculate expression written is the in the question is 2 to the power minus 2 plus 2 to the power minus 4 plus 2 to the power minus 6 plus 2 to the power minus 200. Okay, someone would say, looks like opposite way. What is opposite way? Opposite way is actually it should be 1 by 4. 2 to the power minus 2 is 1 by 4 only. 1 by 4 plus 1 by 16 plus 1 by 64 plus 1 by 256. Oh, actually, I got I came under I came in trouble when I was seeing minus 2. It is pretty that straightforward. You calculate that one. If it looks easy for you, then you can calculate. No one is stopping you. Yeah, what is that? 1 by 4 plus 1 by 16 plus 1 by 64 plus 1 by 256 plus 1 by 100, 1024. That is up to 2 to the power 10 only. 1 by 100, 1024. 2 to the power minus 10. I am asking plus 2 to the power minus 200. Then someone will say, thank you very much, I am going. It's not that easy. That's why we need some intelligence here, that how we can do, and that intelligence is provided by integral calculus. But I was seeing here and there, is there any way to convert a discrete function into continuous function? Because if integral calculus talk about calculation of area, then area in a graph, then area in a graph can be calculated only for the continuous function. If that is continuous function, then tell me what is discrete function. Discrete function is this is discrete function. If x equal to, okay, the question is 2 to the power minus 2 plus 2 to the power minus 4 plus 2 to the power minus 6 plus 2 to the power minus 200. How much it is? If this is the question, then the answer is divide it into n different parts. In the past video we have already talked about it. Divide into n different parts. Then each part is 2 to the power minus 2, 2 to the power minus 4, 2 to the power minus 6. Okay, let's take n number of terms. There can be many terms. Then let's take n number of terms. If I take n number of terms, the last will be 2 to the power minus 2 into n, because first is 2 to the power minus 2 into 1. Next is 2 to the power minus 2 into 2. Next is 2 to the power minus 3 into 2 into, I'm sorry, 2 to the power minus 2 into 3. So everywhere 2 to the power minus 2 is there. 1, 2, 3, 4 is growing like that. Okay, let's take n term. Then last term will be 2 to the power minus 2 into n. There are n terms. Let's divide into n different parts because all are exclusive to each other. What do you mean by exclusive to each other? Exclusive to each other is everyone's result is not affecting other. Like if I toss a coin 3 times, then tell me if first time it is head, then what will be next time result? Independent. Does not depend upon the first time or last time or whatsoever. Every time if I toss a coin, all are independent to the previous time. Doesn't make any sense. Doesn't make any sense. Okay, if I am kind of if I am going for a if I am going for a some run, if I am going for a run on the ground, some competition is going on, and then I run, and I become victorious. Okay, okay, one chance. Next chance, next year again I am participating in a competition, and I am running, and I am not victorious. Okay, then someone would say, did you see one prior to you, your teammate had won the running race prior to you in some other event of running race. Is it that affected you? Because when he won, then you won. Next year he lost, and you lost. This proves that my result is dependent upon my teammate's result. I get enthusiastic because my teammate did. He won his race. Then it is something like a push to me that I can also do it. Then it is dependent. My result is dependent upon the previous result. But if I toss two coins and if I say that second time if I toss a coin it is coming head, then what is the probability that first time the coin was head? There is no dependence. Doesn't make any sense. Similarly, if I'm trying to calculate addition and by that if I divide my problem into n different parts, and if I say second part is 2 to the power minus 4, then how much it is dependent upon the first part? Not dependent. Okay, first part is separate 2 to the power minus 2. This part is separate 2 to the power minus 4, 2 to the power minus 6. There is no dependency. If there is no dependency, then I can divide my problem in n different parts. And then each part, if I talk, then each part I can now represent as 2 to the power minus 2x. Means in notebook I am writing 2 to the power minus 2x plus 2 to the power minus 2x plus 2 to the power minus 2x. All look same. Okay, then what is the inside story? Inside the story is x is variable. Inside the story is x is variable. In first 2 to the power minus 2x, x is 1. In next 2 to the power minus 2x, x is 2. In next 2 to the power minus 2x, x is 3. In next 2 to the power minus 2x, x is 4. Last 2 to the power minus 2 and x is n, and there are n number of items we have taken. Means I can say any particular item, if I divide it into n different parts, then any particular item is 2 to the power minus 2x. Summation summation x equal to 1 to n, x equal to 1 to n function over x. Function over x will get added n times. Function over x plus function over x plus function over x, x times. First function over x is is when x equal to 1. Next function over x is when x equal to 2. Okay, disclose your function over x, and that is 2 to the power minus 2x. And then it will become 2 to the power minus 2 to the power minus 4 minus 6 and so on. Okay, we will compute it through the kind of successive approximation. Successive approximation, many times we have talked it, that in successive approximation we have this is at x-axis, and when x equal to 1, x equal to 0, x equal to 1, then I have a function over x, and that is 2 to the power minus 2. 2 to the power minus 4, 2 to the power minus 6, 2 to the power minus 8. There are verticals at different x, and this vertical height is called function over x. This is what the summation x equal to 1 to n function over x. Actually, we are adding verticals when x equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on up to n. We are adding this vertical. Addition of vertical, if I touch all the top point, first is 1, 2 to the power minus 2, 2 to the power minus 4, 2 to the power minus 6. If I touch all the top point and if I draw a line, that line curve is function over x, and that is 2 to the power minus 2x, but it is not continuous. It is a discrete function. The function is forcibly generated by touching all the points. This function is typically called point mass function, because this is a point mass. Mass is there, but it is pointed. One line is there. If I connect top of all the line, it will draw a function that is a point function, and it is not a continuous function. Here I cannot use integral calculus, because integral calculus calculate the area under a function. If this is a function, if I do fx dx, it will calculate area underneath it, and this fx is 2 to the power minus 2x, and we don't want area underneath it. We just want addition of all the pillars only. That's it. Then how we can calculate integral calculus here? If I have two pillars at x equal to 1 and x equal to 2, there is a gap and it forms a sub area between any two pillars. X equal to x and x equal to x plus 1, there is a sub area. Between x equal to n and x equal to n plus 1, there is a sub area. Okay, so if I say if I add all n sub area, where sub area starts from 1 to 2 and goes from 1 to 2, 2 to 3 of x value, goes till n to n plus 1, then there are n number of sub area, and it will hit another function, continuous function called gx. This is gx and it is a continuous function. Okay, or someone can say gx is like this, but it is a continuous function. It is not fx, it is gx, another function that is continuous. And this function, underneath there is a area. Area is divided into n sections. First section is between 1 and 2, second section is between 2 and 3, and last section is between n and n plus 1. So there are n sections. Okay, if I see the fx, that is at x equal to 1, fx is 2 to the power minus 2. Can I say 2 to the power minus 2 is same as the area between 1 and 2? Means 1 and 2 limit gx dx is same as 2 to the power minus 2. Can I say the area between 3 and 4 is same between in gx is same as the height at 3, left hand side 3? Means 2 to the power minus 2 into 3 is same as 3 to 4 gx dx. What is your gx dx that we have to find? This is what we have seen in the previous session. In this session, we will take left hand side. Left hand side means if I have something called gx, then we will take x equal to 1 and x equal to 0. Left hand side area will correspond to right hand side vertical. Right hand side vertical is x equal to 1. Then we will take area between x equal to 1 and x equal to 2, and then it will hit gx, and the sub area will be same as fx height on right hand side, that is x equal to 2. What I am trying to say, that if I take any x equal to x, then fx is 2 to the power minus 2 into x. Then it will be same as the left hand side area between x minus 1 and x, that will go and hit gx. Means fx at x equal to x equal to limit x minus 1 to x gx dx. All together I can say 2 to the power minus 2 into 1 plus 2 to the power minus 2 into 2 plus 2 to the power minus 2 into 3 plus 2 to the power minus 2 into n is same as 0 to 1 gx dx plus 1 to 2 0 gx dx up to n minus 1 to n gx dx. Same. If I take any x, then here it will be x minus x to x, left hand side. Anyway, through this we will try to find gx. There can be third way, where if I have x equal to x, if I have the, if this is fx 2 to the power minus 2 to the power minus 2x, and this is x equal to 1, this is x equal to 1, then I will take area strip that will have width of 1 but half left side half right side of x equal to 1, means fx at x equal to x will be same as integral x minus half to x plus half gx dx. All gx will be different. In first session we took x to x plus 1 gx dx. Here we will take x minus 1 to x gx dx. This gx dx will be different than just gx dx. Or we will take x minus half to x plus half dx dx. This dx dx will be again different. Okay, so we'll start fx equal to x minus 1 to x gx dx. Okay, if I don't take the limit, then fx equal to gx dx. Gx will be dfx by dx. Gfx is 2 to the power minus 2x. By dx, it will come as minus 2 logarithmic of 2, log base e, logarithm, natural log, logarithmic of 2 into 2 to the power minus 2x, differentiation. Okay, that will come. So we will start with that only. Gx equal to differentiation of fx minus 2 into logarithmic of 2 e to the 2 to the power minus 2x. Okay, we will start with this as gx. Then how much it will come? Minus 2 into logarithmic of 2 to the power minus 2x. Integration will be 1 by minus 2, opposite. 1 by nt integral, differential I can say. 1 by minus 2 into 2 logarithmic of 2 minus 2 into logarithmic of 2, 1 by into 2 to the power minus 2x. That will be integral. Same is in numerator also, it will cut each other. Only 2 to the power minus 2x will remain. Limit is x minus 1 to x. 2 to the power minus 2x minus 2 to the power minus 2 x minus 1. It will become like minus 2 to the power minus 2x into 2 to the power 2 minus 2 into minus 1 will be 2 only. 2 to the power minus 2x I can take as a common, and 2 to the power minus 2x in bracket, it will come as 1 minus 2 to the power 2. I think so it is all right, and I did not try. It will come as 1 minus 2 to the power 2. That will come as minus 3. So net it will come as minus 3 into 2 to the power minus 2x, where fx is 2 to the power minus 2x, and here we are getting, when I kept gx as minus 2 into logarithmic of 2 to the power minus 2x, then it at the end result is coming as minus 3 into 2 to the power minus 2x. Minus 3 is extra. So we will divide by minus 3 now to have the same result. Now gx is minus 2 logarithmic of 2 into minus 1 by 3, 2 to the power minus 2x. Now we will try again with new gx. This is successive approximation with x minus 1 to x as a limit. If I take integral, then it will come as minus 2 logarithmic of a into minus 1 by 3 into 2 to the power minus 2x by minus 2 logarithmic of 2. They will cut each other. Minus 1 by 3 will remain. And then we will place the limit. If I place the limit, it will come as minus 3 into 2 to the power minus 2x, the way it came. Minus 3 gone. 2 to the power minus 2x. It is exactly same as fx. Means if I take a continuous function, if I have a discrete function at 2 to the power minus 2x, then if I take a continuous function, that is 2 minus 2 logarithmic of 2 into minus 1 by 3 e to the power 2x, and if I calculate area underneath it, that area will be nothing but summation of all the vertical one. We took only for one part x. Makes sense? Now we will try summation of all the through this integral calculus. Integration, we took the left hand side. If this is gx, then this is x equal to 1, 2, 3, 4. We took 0 to x as the first subsection. 1 to 2, another subsection. Last one was n minus 1 to n, another subsection. That go and hit gx. Means if I want sigma summation x to 1, x equal to 1 to n, fx dx, sorry, fx, it will be same as integration from 1 minus 1 to n gx dx. That is 0 to n gx dx. Makes sense? Okay, what is dx dx? Dx dx is minus 2 into logarithmic of 2 into minus 1 by 3, 2 to the power minus x, then dx. If I do dx, then it will be 2 to the power minus 2x divided by minus 2 logarithmic of 2. They will cut each other, and minus 1 by 3 would remain now. And then we have 2 to the power minus x, 0 to n. Then it will come at 2 to the power, 2 to the power minus 2 into x, 2 to the power minus 2n minus 2 to the power minus 2 into 0, 1. It will come as minus 1 by 3 in bracket into in bracket 2 to the power minus 2n minus 1. If I settle down negative, it will come as 1 by 3 into in bracket 1 minus 2 to the power minus 2n. It is exactly same as what we saw in the previous session. That was again 1 by 3 into 1 minus 2 to the power minus 2 to the power minus 2, and same thing is coming. Okay, if I say, then what is the actual result I have to fill in the examination? 2 to the power minus 2 plus 2 to the power minus 4 up to plus 2 to the power minus 200. Minus 2 to the power minus 200 is same as 2 to the power minus 2 into 100. N is 100. Then the actual result will be 1 by 3, and in bracket 1 minus 2 to the power minus 200. That is the result, 2 into 100. Okay, if n tends to infinity, then infinite series summation, then it will become 0, and then it will become 1 by 3. Same result what we saw. Third one we will take, that is from x minus 1 by 2 to x plus 1 by 2. The vertical bar is in middle of the sub area what we are taking. Left side high half, right hand side half. We will take sub area. Okay, if that is the sub area, then how it would go? Then we have here 2 to the power minus 2x equal to gx will start with the same thing, minus 2 into logarithmic of 2. 2 to the power minus 2x integration will be 2 to the power minus 2x by minus 2 logarithmic of 2. They will cut each other. 2 to the power minus 2x, that limit is from x minus half to x plus half. Okay, then how much it will be? X plus 1 by 2 will be 2 to the power minus 2, x plus 1 by 2, 2 to the power minus 2x minus 1, minus 1. This is what I think so. Minus 1 minus 2 to the power minus 2 x plus 1, because minus 1 by 2 will become plus 1. 2 to the power minus 2x I can keep outside, and it will become 2 to the power minus 1 minus 2 to the power 1. That is 1 by 2 minus 1 by 2. 2 to the power minus 1 is 1 by 2. 2 to the power 1 is 2. 1 by 2 minus 2. That will come as minus 3 by 2. I never tried this. Minus 3 by 2 means the result is coming as minus 3 by 2, 2 to the power minus 2x. But wanted is 2 to the power minus 2x. Minus 3 by 2 is extra. Not to have this, we will multiply with 2 by 3 minus, so that it will go away. We'll try again. Earlier gx was minus 2 into logarithmic of 2. Now gx will be minus 2 into logarithmic of 2 into minus 2 by 3 into 2 to the power minus 2x. This big is gx now. We'll try again. Okay, gx dx integration will be integration of 2 to the power minus 2x will be 2 to the power minus 2x divided by minus 2 logarithmic of 2. They will cut each other. Minus 2 by 3 will remain outside, and 2 to the power minus 2x. Limit will be we 1 minus half to n plus half. Left side, the central part we are taking. 1 minus half is 1 by 2. 1 by 2 to n plus 1 by 2. 2 to the power minus 2x n plus 1 by 2 x. Then it will become 2 to the power minus 2n into 2 to the power minus 1. 2 to the power minus 1. Okay, minus 2 to the power minus 2x. X is 1 by 2. 1 by 2 will cut each other. 2 and it will become 2 to the power minus 1. Here also 2 to the power minus 1. Here also 2 to the power minus 1. 2 to the power minus 1 I can keep outside. Then it will become minus 2 by 3 into 2 to the power minus 1. And in bracket 2 to the power minus 2n minus 1. If I settle down, then it becomes 2 by 3 into 2 to the power minus 2. And in bracket 1 minus 2 to the power minus 2n. 2 gone, 1 by 3. 1 by 3, 2 to the power minus, 1 minus 2 to the power minus 2n. Means it is exactly same previous two things we take. Anything someone can take. Make sure that the width of the integration is 1, because we make discrete at 1 interval only. We have seen half interval also, where limit will go minus 1 by 4 to plus 1 by 4. That we have seen. Anyway, if n tends to infinity, then it will again become 1 by 3 only. With all measure, result is coming for infinity summation is 1 by 3. Otherwise, for up to n items, then it will be 1 by 3, 1 minus 2 to the power minus 2n. Okay, amazing, mind blowing. Someone can try. This is not mentioned in any of the book this way. Integral calculus, someone can lift elephant also. Means that is the most enjoyment thing. This is what I would say. When you solve a problem, enjoy it. That is the requirement. Otherwise, you won't like solving the problem. You should get some that you were not getting earlier. Can someone believe that if someone is given 1 by 4 plus 1 by 16 plus 1 by 64 plus 1 by 256 plus 1 by 1024 plus 1 by 4096 plus infinite item, it will come to exactly 1 by 3. Can someone imagine? First of all. Second is that there is only one procedure to calculate all the summation series. This is what we are doing. Amazing, mind-blowing, head hitting in the wall, and no one would have dreamt about it that any summation can be done through integral calculus. Not available in any of the book. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.